This is Trig, lesson 2.1. We are at part 2 on page 3 of our notes. And the second objective of this lesson is to find function values for some very special right triangles. If you remember from geometry, we had something called a 30, 60, 90 triangle. And these were degrees in degrees. And a 45, 45, 90 triangle. And these are going to be our two special triangles we want to know about. Okay? They're very valuable for our trigonometry. So first of all, let's talk about a 45-degree angle in a right triangle. Well, first of all, you know that the sum of the angles of a triangle equal 180 degrees, right? Sum of angles of a right, or any triangle really, of a triangle equal 180 degrees, always. So that's an angle from rule from geometry. So if we've used up 90 degrees and 45 degrees, if you subtract those from 180, you have 45 degrees left. 45, 45, 90. So if these two angles are congruent, then what we also learned in geometry is that their corresponding opposite sides are congruent also. So if these angles are the same, we called them base angles, being congruent. We called this triangle isosceles because two sides were congruent. And since those angles are congruent, their opposite sides are congruent. Okay, and of course this opposite side from the right angle is the hypotenuse. So the two legs of the right triangle are equal. So this is always true in a 45, 90 triangle. Now if you remember back to the last lesson, 45 degrees is also the same thing as pi over 4 radians, right? Okay, so this, is also about pi over 4 radians. So we're going to see that in a minute. So this says, assume each leg of a triangle equals 1. So let's say that these lengths are 1 meter or 1 inch or something, okay? We could find the hypotenuse by doing Pythagorean theorem. Let's come down here and think, what could that, if both those legs are 1, we would plug in 1 for A and 1 for B, because those are the legs, and we would be looking for the hypotenuse, C. This would be C squared. 1 plus 1, because 1 squared is 1. 2 equals C squared. So C is plus or minus the square root of 2. So this hypotenuse is the positive square root of 2. Okay? And we're supposed to find the 6 trig functions for 45 degrees. Now you could actually look at either angle here, but since we're kind of used to using, let's use this angle, like this is our theta right here, okay? This is my 45-degree angle. And I want to find sine. Now, go back to your list of rules. Sine is opposite over hypotenuse. Keep your rules handy as you're doing your homework. Keep them right there beside you so that you'll remember. Sine is opposite over hypotenuse. It's 1 over the square root of 2. That is not rationalized. 1 over square root of 2, I'll have to multiply the top and the bottom by square root 2 over square root 2, which is like multiplying by 1. And my numerator becomes square root 2, and my denominator becomes 2. Square root 2 over 2 is sine of 45 degrees. This is something we need to memorize. It's so important. We use it all the time. So, cosecant, I'm not going to memorize that one. I just really need to focus on these right here, these 3. Because I know the reciprocal. Once I know sine, I can just flip it over and get square root 2 for cosecant of 45 degrees. You're welcome to memorize that if you'd like to, but my memory space is short. I have to, only memorize what I need to. Let's talk about cosine of this angle. Cosine, go back to your rules, is adjacent over hypotenuse. Adjacent over hypotenuse, 1 over square root 2. Well, guess what? Cosine of 45 degrees is the same thing as sine of 45 degrees. And if we rationalize it, we can go do it again, but we're going to get square root 2 over 2. That's something to memorize. Cosine of 45 degrees is square root 2 over 2. They're the same because, it's the x and the y of the triangle. It's the two sides that are congruent. And then tangent is opposite over adjacent. Tangent is 1 over 1. Tangent is just 1. Tan of 45 degrees is 1. We better scoot over here and do secant of 45 degrees. It's the reciprocal of cosine. Again, it's just square root 2. And cotangent of 45 degrees, the reciprocal of 1 is 1. And there's our 6 trig functions for a 45, 45, 90 triangle. Also called the angle pi over 4. If this was called pi over 4 instead of 45 degrees, the answers would all be the same. Because 45 degrees and pi over 4 are the same angle measurement, just different units of measure. All right, let's talk about that 30, 60, 90 now. If we start with, where is it? It says, right triangle, start with an equilateral triangle. So do you remember the word equilateral means all the sides have the same length? So look at this outer triangle. It says, let's assume they all have a length of 2. If this whole length is 2, all 3 sides are 2, and then I cut this triangle right down the middle, then this length over here would be 1, right? Because this used to be 2, and we just cut it in half. Now, if you have an equilateral triangle, all the sides are the same, then all their angles measure the same. And if you have 180 degrees and you divide it by 3, you get 60. Every angle is 60. 60, 60, this whole angle is 60. Well, when we cut it in half, now we have a 30-degree angle here. So this angle is 60, this angle is 30, this angle is 90. That does add up to be 180 degrees. Let's just look at this little right triangle over here. If this length is 2, we know that the base length is 1 because we cut the base in half. And now we'll do Pythagorean theorem to find, I'll call this side B. You might want to call it A, B, and C. And so to do Pythagorean theorem, let's just come over here. A squared plus B squared equals C squared. 1 squared plus, we don't know this leg squared, equals the hypotenuse squared, which is 2 squared. 1 squared is 1, 2 squared is 4. Subtract 1, b squared equals 3. So b equals plus or minus square root 3. All right, b is this length, so we're going to use the positive square root of 3. Okay, so now that we know all 3 sides of the triangle, we can go answer our 6 trig functions. And they want me to use the 60-degree angle. Sine of 60 degrees is opposite over hypotenuse. Square root 3 over 2. Cosine of 60 degrees is adjacent over hypotenuse. 1 over 2, or 1/2. Tangent of 60 degrees is opposite over adjacent. Square root 3 over 1, which is just square root 3. All right, now we just do the reciprocals. The reciprocal of sine is cosecant, and we're going to get 2 over square root 3. And then we're going to rationalize that. I'm going to multiply the top and the bottom by square root 3. And I get 2 square roots of 3 over 3. Now, for cosine's reciprocal, we call it secant. You do the reciprocal of 1/2, which is 2. And tangent's reciprocal, that was square root 3 over 1. So cotangent of 60 degrees will be 1 over square root 3. And we'll want to rationalize that again so that we don't have a radical in the denominator. 1 times square root 3, square root 3, square root 3 times square root 3 is 3. These are the 6 trig functions for 60 degrees, or pi over 3. It's the same thing as pi over 3 radians. So if I ask you what is sine of pi over 3, it's the same thing as sine of 60 degrees. It's square root 3 over 2. Okay? So this is in degrees, this is in radians. Now, let's go look at the 30-degree angle and fill this in. Now, here's our 30-degree angle up here. So we're going to look, when we say sine of 30 degrees, we're going to say opposite over hypotenuse. We're going to say 1 over 2, 1/2. Now, do you remember a minute ago, cosine of 60 degrees was 1/2. Now, sine of 30 degrees is 1/2. And cosecant would be its reciprocal. Cosine of 30 degrees. Cosine is adjacent over hypotenuse. You see, the adjacent side has to share the angle. So it's square root 3 over 2. I'm sorry, it's square root 3 over 2, right? That looks familiar. That was sine of 60 degrees. This is cosine of 30 degrees. We're going to see an important identity with this, how these things go together, okay? And then the reciprocal of cosine is secant. Flip this guy over and get 2 over the square root of 3. Rationalize it. We did that up here. Do you remember? And we got the answer 2 square roots of 3 over 3. And then tangent of 30 degrees. Tangent of this 30-degree angle is opposite over adjacent. 1 over square root 3. Let's rationalize that. Oh, we did that earlier. We got square root 3 over 3. There's no need to show me all those steps, okay? And then cotangent is its reciprocal of tangent. So just flip this over and get square root 3. You can see a lot of similarities in the 30-degree angles and the 60-degree angles, can't you? Okay, so these sine, cosine, tangent of 60 degrees, or pi over 3, need to be memorized. And sine, cosine, tangent of 30 degrees need to be memorized. Now, another name for 30 degrees I have written up here is pi over 6. We learned that in the last lesson. So if I say, what's sine of pi over 6? You're thinking, oh, that's the same as sine of 30 degrees, which is 1/2. Okay, so all of these answers would be the same. Now this says down here, can a calculator be used to evaluate trig functions? Well, yes, but not to give us answers like this. Our calculator cannot give us exact values like this. They give approximate values of trig functions. Right now, we want exact values. That means we want the radicals, okay, the square roots. When these exact values are irrational, when they have square roots, we need the exact values. These exact values cannot be obtained with a calculator. They can only give you a rounded decimal. So that's a little frustrating that the calculators really of no help to us yet. So, on the next page, these important rules that I said, let's remember the 30 degrees. Remember it was 1/2, square root 3 over 2, square root 3 over 3 for sine, cosine, tangent. For the 45 degrees, do you remember we got square root 2 over 2, square root 2 over 2, 1. See? And for the 60 degrees, we got square root 3 over 2, 1/2, square root 3. This needs to be committed to memory. These are our special angles of trigonometry. And our calculator can only give us decimals. It can't give us the exact solution. These values need to be memorized. We're going to put them on our unit circle. Okay? Later. Not today. All right. Let's look at another set of rules. Now, in trig, we call these identities. An identity means, you know, it's like an equation where the left side equals the right side. But it's going to give us a rule that we can substitute with. Okay? So a fundamental identity is really just an equation of two things that are equal to each other, obviously, that use our trig words and help us for substitution into other more complex problems. So I've been saying that sine and cosecant are reciprocals. So this is the mathematical way to say that. If you do the 1 over cosecant, you would get sine. And vice versa. If you do 1 over sine, you get cosecant. If you have cosine, its reciprocal is secant. Secant's reciprocal is cosine. Tangent, if you flip tangent over, you get 1 over cotangent. Cotangent is the same thing as 1 over tangent. Okay. Now, here's another important thing that I could prove to you real quickly. Tangent, another name for tangent is sine over cosine. Now, the reason that's true, do you remember that we said, let's come down here and do this little proof. Do you remember that SOHCAHTOA, first of all, I'm going to write it down, SOHCAHTOA, and if we decided, I want to know that sine of theta is, let me just write this down, opposite over hypotenuse, and cosine of theta is adjacent over hypotenuse. And if I want to find out what sine theta over cosine theta is, if I want to do the division of these two, I would put opposite over hypotenuse, that's sine theta, over cosine theta, which is adjacent over hypotenuse. Now, I'm dividing fractions, so that's the same thing as the numerator multiplied by the reciprocal of the denominator. Oops. So all I did was, instead of dividing the fractions, I multiplied by the reciprocal of the denominator. The hypotenuses cancel. You get opposite over adjacent. So notice I did sine over cosine. I got opposite over adjacent. That's the name for tangent. So I just proved to you that this is an identity, that sine divided by cosine, another name for that is tangent. So here is this rule that tangent of theta is the same thing as sine theta over cosine theta. We just went the other way. Okay? And well, I say vice versa, but you know, kind of, it's reciprocal. Cotangent would be cosine over sine, because tangent and cotangent are reciprocals. You would do the reciprocal of sine over cosine, and you get cosine over sine. So these are fundamental, we call them reciprocal identities. So let's use these identities to work this next example. This says, given sine theta is 2/3 and cosine theta is square root 3 over 3. Find the value for the 4 remaining trig functions. Okay, so let's think. If we know sine is 2/3, then we could use this identity right here to find cosecant. It would be 1 over sine. 1 over 2/3 is just its reciprocal, 3/2. Okay, if we know cosine is square root 3 over 3, then secant is 1 over cosine. In other words, flip it over. 3 over square root 3. Let's rationalize that. We get 3 square roots of 3 over 3. Oh, the 3's in front cancel out, and our answer is just square root 3. Okay, so the reciprocal of square root 3 over 3 is just square root 3. Tangent is sine over cosine. I think they want me to find the 4, so they want me to find that. Sine is 2/3 over cosine is square root 3 over 3. So I'm going to get 2/3 times, remember, multiply by the reciprocal of the denominator. The 3's cancel. We get 2 over square root 3. We have to rationalize it. Are we having fun yet? And we get 2 square roots of 3 over 3. Wow. And then secant would be the reciprocal of that. Now, do you remember our answer was 2 over square root 3, and then we rationalized it? So secant would be, oh, wait a minute. That is supposed to say, here's another typo, y'all. Sorry, I borrowed these notes from somewhere. The reciprocal of tangent is cotangent. That should say C-O-T, cotangent theta. The reciprocal of tangent would be square root 3 over 2. So I'm going to cut down on my work if I use the number before I rationalized it. They're all equivalent, but that way when I flip it over, I don't have to rationalize it again. Okay. Oh boy. So that brings us to the end of page 5 in our notes. Again, I'm going to pause video part 2. so our videos don't get too long. And then we'll pick up with part 3.